Larry McDowell. I'm the senior principal and one of the founding principals of Using Case Engineers based out of Atlanta, Georgia. We now have a branch office in Raleigh, North Carolina. Directors always looking for ways to speed things up. So one of the things we always do when we start figuring out a framing plan is, okay, how can we make this framing into the least number of pieces? Because generally they bid the job a couple ways. One is by tons, but they also do it by what they call picks, and that is how many times they have to pick up a beam. And it doesn't really matter if the beam weighs 2,000 pounds or 20,000 pounds. Generally, the crane is large enough, but it's just a matter of picking it up, setting in place, and bolting. And we always try to use parts of the construction, like the metal deck, for example, spanning between the beams. We always try to maximize the spans, within reason, so we can minimize the number of beams that, so some people will take a 30-foot bay and break it into 4 7.5-foot spans using a 2-inch deck. What we found is it's much more economical, and most fabricators will agree to break it into 3 spans using 3-inch deck. Anyway, that cuts out a third of the number of pieces right off the bat of all the filler beams. So, we're looking for places like that we can speed up the erection. First thing you have to understand, what is the fire rating for the building itself? What do they need in the floors? Because you're spinning your wheels if you pick a deck system that does not give them a 2-hour rating, or if they only need a 1-hour rating, you can thin things up. Like we still would, for example, use longer spans, but we might consider a lighter deck or a shallower deck if we only need a 1-hour rating for the floors and things like that. You have to get that ironed out, because that does affect your modeling. If you have, a 1-hour floor or 2-hour floor, there's going to be a difference in weight that's going to be substantial when you start looking at your lateral loads and whatnot. A lot of times they're not, you have to push them to make these decisions early on. Actually, very early, I write up a little list for the architect. Architects love bullet points because when they respond, they can just check them off. There's a lot of them really like that. So we send them a list, and that's one of them is the rating for whether they have any elements that are going to be architecturally exposed, that going to need special consideration or special connection details, or whatnot. One of the other things that I really encourage all the younger people, they really get into the modeling. The analysis part is so easy for these people coming out of school compared to people like me that it was not second nature. I mean, it's something I had to learn, and they need to get out of the model sometimes and go to the field. They need to go see what they've detailed and see how it goes together, or maybe it doesn't go together. Or see what kind of problems they've created, and making little, tight joints, or they have large beams framing into small beams. That's another one. A lot of the analysis programs will run successfully a model with beams that the framing doesn't make sense, where you have a large, a W24 framing into a W21, which typically means you not only have to cope the top flange like you would on every connection, metal deck at the same elevation, but you have to cope the bottom flange, and that's a no-no from every fabricator. Just think it through. Think about the orientation of the filler beams versus the girders. A lot of times it makes a difference from a mechanical standpoint in terms of trying to make the ceilings work, to keep the ceilings up high, and so that mechanical engineer doesn't have to have real flat, wide ducts. That's why we try to get all of our preliminary concepts for framing plans with depths out to everybody, including the mechanical engineer, We generally on a steel building, we'll have the girders, which are spanning the short direction, and the filler beams spanning the long direction. Because the girder's taking more load, it needs to be deeper, but your filler beams also need to be deeper. They're taking less load per beam. So anyway, you come out with a reasonably balanced structural depth. Because if you do it the other way, sometimes you end up with real deep girders and real shallow filler beams, and then that doesn't really help the mechanical engineer. He would prefer everything is all the same elevation. And when they get to the sprinkler lines, the same thing. They like sprinkler lines tight up against the structures. So if you can keep your overall structural system in both directions reasonably close, I mean, I'm saying within, 3 to 6 inches of the same in each direction, it makes life easier for the architect and mechanical engineer. Just make sure when you create your model, always keep in mind all your load paths and everything. Make sure everything makes sense. Yeah, and it's such a reward for me to go back out and see a building that I designed. And on the other hand, it's kind of a heartburn when you go out to see one of your structures you did 30 years ago is being torn down and putting something else. I did when I first moved to Atlanta. I did bridges. I designed 4 of the bridges right downtown going across the expressway, and they since widened the expressway, and those bridges are gone. But it happens, But I do enjoy seeing the product